Hey guys, welcome to our physics pandemic education lesson 2. Today we're going to work through that same packet as yesterday, the unit 4 post-exam review. And today we're going to complete questions 11 through 20. That'll be it. I'm going to just do the same thing. I'm going to kind of lay out the start of each problem and ask you to do the work to complete it. And then there will be a Google quiz where you can kind of select your answer choices, A, B, C, and D. And that will help me figure out if there's any problems that we should do as a whole group in another video or via a Zoom session. So let's get into it. All right, guys, so we've already done problems 1 through 10 on this Unit 4 Work, Power, and Energy Post-Exam Review. Today we're going to move on and start doing problems 11 through 20. Let's get going. So again, just like last time, I'm going to walk through kind of the setup for each of the problems and then leave it to you to actually do the calculations. As a reminder, there is a free calculator app that you can use on your smartphone. So here we go. Problem number 11. What is the minimum, with what minimum speed, must a gazelle leave the ground for it to raise its center of mass up 3 meters to clear a fallen tree with a final velocity of 5 meters per second? So we want to know our initial speed, VI. Give that a question mark. We know our final velocity, VF, is 5 meters per second. And we know it needs to move up 3 meters. So I'm going to say our initial height, HI, is 0. And we're going to call HF 3 meters. Okay? Because again, it doesn't matter where we start, it just matters that from our starting point, we go up 3 more meters. Now, this problem doesn't necessarily look like it initially, but this is actually another conservation of momentum problem. Sorry, not conservation of momentum, conservation of energy problem. So we're going to start with that same formula from problem number 10, where we've got KEI plus PEI equals, KEF plus PEF. All right, let's plug in like the bits and pieces for each of those formulas. We've got 1/2 mvi squared plus mghi equals 1/2 mvf squared plus mghf. Remember, G is positive 9.81. All right, so we want this piece, we know this piece, and this piece, but we don't know M. Whenever we see a problem that talks about we're doing conservation of energy and it just says raising its center of mass, this is one of those problems where we can eliminate M. I say eliminate, really what we're doing is we're taking this entire problem, both sides, and we're dividing by M. And because M is in every single component of this equation, we can actually cancel it out of the entire equation because M divided by M is 1. Anything divided by itself is just 1. So we are left with this equation 1/2 VI squared plus GHI equals 1/2 VF squared plus GHF. All right, from here you can just plug in your numbers and solve for VI. Don't forget that you need to take the square root at the very end of the problem. All right, number 12. It's another conservation of energy problem. So we've got a 900 kilogram roller coaster, M equals 900 kg. It's starting at rest, so that means our initial velocity is 0 meters per second at point W. So our initial height, HI, is 100 meters. And we want to know the KE, kinetic energy, at point Y. All right, point Y, our final height, HF, equals 50 meters. All right, so conservation of energy, we'll set it up. KEI plus PEI equals KEF plus PEF. Okay, Plugging into bits and pieces to solve. 1/2 mvi squared plus mghi equals. Instead of writing 1/2 mvf squared, I'm actually going to just leave it as kef. And I'm doing that because the problem actually asks for kinetic energy and not velocity. We could solve for final velocity, but we'd actually be adding extra steps into it. So like, let's not even bother. So then plus mghf. Plug in your values, get kef all by itself, and pick your answer. All right. Ooh, this is a good one. A basketball player has momentum. Remember, momentum is P of 200 kgm per s. He slows to a momentum, so this is an initial. If we're slowing to a new momentum, there's a final. 125 kgm s. We need to find his impulse. We're again going back to my favorite formula. J equals F delta T equals M delta V equals delta P. I think I flipped these two around, but it doesn't really matter. You can put them in any order and you're good. I don't care about this or this. I want to know J, and remember delta P really just equals our final minus our initial. If you flip the order of these and do initial minus final, you're going to get the wrong answer. It's really important that we always do final minus initial whenever we're talking about a change in something. Okay. Next one. How much potential energy does a 1 kilogram cat have in a 15-meter tree? Well, PE, where in this case we're talking about GPE or PEG, I know some of you like. They both equal mgh. Our m is 1 kilogram, h is 15 meters, and then just don't forget that g is positive 9.81. And that's a given. You don't need to write it. I'm just writing it to remind you that it's positive and not negative. All right, moving on. How much kinetic energy does a 1 kilogram cat have running at 3 meters per second? All right, so mass is 1 kilogram. V equals 3 meters per second. We know kinetic energy is 1/2 mv squared. Pretty straightforward. Okay, number 16. You do 50 joules of work on a 10 kilogram box. So work done is 50 joules. Let me make that better. 50 joules. The box loses 10 joules of heat. So we're going to say work lost equals 10 joules. Due to the flow through friction, blah, blah, blah. What is the velocity of the box after work has been done on it? So I want you to remember this. Work net is equal to a change in kinetic energy. Let me add in that our box's mass is 10 kilograms. And it didn't say it in the problem, but remember I've told you that these problems we always start at a VI equals 0. So our net work equals a change in kinetic energy. So that really means that the work done minus the work lost equals, that's our work net, a change in kinetic energy. So that'll equal 1/2 mvf squared minus 1/2 mvi squared, because this is kef minus kei. Final minus initial. Plug in your numbers, and you'll be able to solve for your final velocity. Okay? Again, because we're squaring velocity, you'll end up needing to take a square root. Please don't forget to square root your answers at the very, very, very end. Okay, a kid applies a 1 Newton force to his 3 kilogram wagon, m equals 3 kg. Initially at rest, so VI equals 0 meters per second, for a period of 5 seconds. We're assuming there's no friction. We want the velocity at the end. Okay, here's another one. Same time, same favorite formula. F delta T equals m delta v. And I'm just pulling this from this formula right here. Instead of using the outside 2, I'm using the inside 2. Just don't forget, delta V really equals VF minus VI. So we're really saying F delta T equals M VF minus VI. Okay? Use your inverse operations to get VF by itself. Don't forget, we'll divide to move M over and then add. Okay? If that didn't make sense, make sure you attend our Zoom meeting so we can talk about it. Okay. God, the second half of this test was much easier than the first half, I feel like. All right, you have a velocity of 10 meters per second and a momentum of 500 kilogram meters per second. What is your mass? Well, P equals mv. Plug it in, inverse operations, get mass all by itself. 100 joules of work are done in a period of 10 seconds. How much power is produced? Well, power is work done over time. So power, capital P, different from lowercase p. I know they look the same, but make sure that you are distinguishing for yourself in your notes. So power, work done over a period of time. Look at that, plug it in, solve for your variable. All right, last problem for the day. Jack, mass of 85 kilograms, so let's write that down. M equals 85 kg. Is at rest. Our initial velocity, if we're at rest, is always 0 meters per second. At the top of a 100-meter hill, so H initially is 100 meters. He begins to tumble down, and we want to know his final velocity. VF equals, right? What is his final velocity when he is 30 meters from the bottom? So we want to know when his height is 30 meters, how fast is he going? This is another conservation of energy problem. Energy can never be created or destroyed, we can only change it. So we have to say our kinetic energy initially plus our potential energy initially equal our kinetic energy finally plus our potential energy finally. Let's plug in and break down each of these pieces. 1/2 mvi squared plus mghi equal 1/2 mvf squared plus mghf. Take all these little bits and pieces and plug them in here, and you can solve for VF. Now, that's the last problem we're going to talk about today. I want you to notice a few things, though, in every single one of these problems that we've done. The key takeaway is that every single time we are plugging in our givens off to the side and starting with our formulas. It's really important that all of you do the same thing. All right? When I was going through your exams, a lot of you didn't do these pieces. And what happened? It got, curved, so you all did okay, but initially not so much. So, let's get these done, do them the right way, show your work, and you got this. All right, guys, so that's the last little bit of this review packet. Please make sure you are doing all the problems, showing your work, because if you don't show your work, it's not going to be as easy for me to help you when you get stuck. All right, fill in the Google form that's posted on Google Classroom with your final answers. You are welcome to wait to fill that in until after our Zoom meeting tomorrow if you have any questions. I say tomorrow we're going to have a Zoom meeting from 10:30 to 11:30 on Thursday, March 19th. Again, these meetings are totally optional for you. They're a nice opportunity, though, for you to either ask me questions or just kind of see each other and maybe hear each other's voices. I don't know how socially distant you currently are, but if you're like me, you need to talk to some people besides the people in your home. Last little thing. The back of your exam has the vocab. I don't know if you can see that, but 10 out of 10 would recommend you do it again. I will post the key for it maybe later today, maybe tomorrow. I haven't quite decided yet, but I want you to keep practicing this and be ready to compare your answers with mine, because the vocab is consistently one of the most difficult pieces for you guys, and it really shouldn't be. These should be gimme points. So, homework, essentially, go through this video, finish answering the next 10 questions, put your little answer choices in the Google form, start practicing this. If you have any questions, comments, concerns, just want to tell me how much you miss me, I miss you too, feel free to send me an email. You can comment on this video, or you can make a comment in our Google Classroom. And I look forward to seeing you all. Love you lots. Bye.